If you've loved the latest James Webb images, you need to see what I'm about to show you. ESA's Euclid Space Telescope has sent back its first batch of photos, and they're some of the best space pictures ever captured. Scientists are freaking out at what they're seeing. Known as Euclid's first light, this photo collection is a tour of the universe's galaxies. These images challenge our ideas on how the universe evolved. They give new insight into dark matter's role in shaping the cosmos. And they let us peer 10 billion light-years into the past. On July 1, 2023, the European Space Agency launched Euclid from Cape Canaveral, Florida. After traveling about 930,000 miles, it joined its siblings. The Gaia and James Webb telescopes were already waiting. All three now orbit around a special point in space called Lagrange Point 2. This location is ideal for studying deep space. It lets telescopes keep the Sun, Moon, and Earth behind them at all times. Nothing interferes with observations. And since L2 keeps pace with Earth's orbit around the Sun, we stay close to our instruments for easy communication. But what makes Euclid different from every other telescope we've built? The answer lies in three key features that scientists have been waiting over 12 years to use. And the results are already changing what we thought we knew about the universe. First, Euclid's ultra-wide lens captures more of the sky at once than any telescope ever has. It gathers light data from billions of galaxies, some as far as 10 billion light-years away. Compared to ground-based surveys, it has 4 times the resolution and 15 times the sensitivity. Second, Euclid measures subtle distortions in galaxy shapes caused by dark matter's gravity. This creates a gravitational lensing map. It's key to understanding how galaxy clusters grow and evolve, and it shows us how dark matter has shaped the universe itself. Third, Euclid creates a 3D map of the universe with 2 advanced instruments. The Visible Imaging System captures ultra-sharp images to measure galaxy shapes. The Near-Infrared Spectrometer measures redshifts, placing galaxies in 3-dimensional space. No telescope has done both at this scale. Between March 25 and April 8, 2024, Euclid took 260 pictures of the southern sky. This covered an area 500 times the size of the full moon we see from Earth. Scientists created a mosaic spanning millions of stars and galaxies, and this is just 1% of what it's planning to do. But scientists discovered something unexpected in the data, something hiding in plain sight that would change our understanding of dark matter forever. This is the Perseus cluster, located 240 million light-years from Earth. This image shows over 1,000 Perseus cluster galaxies, and more than 100,000 faraway galaxies appear in the background. The way these galaxies are organized tells us about dark matter distribution. Gravity might cause dark matter to organize itself into filaments. Where these filaments intersect, galaxies stick closer together, forming clusters. If there were no dark matter, galaxies would be spread evenly throughout the universe. But that's obviously not what we see. Cosmological simulations predicted dwarf galaxies should exist in Perseus too, but these faint galaxies were overshadowed by older stars shining infrared light. They had escaped direct observation for decades, until now. Euclid discovered more than 630 previously unknown dwarf galaxies in a single image. Say hello to irregular galaxy NGC 6822, shining bright 1.6 million light-years away. Edwin Hubble first identified it as a remote stellar system back in 1925. Now, almost 100 years later, Euclid is sending back high-resolution images of the entire galaxy and its surroundings. But these stars held a surprise. Many of them have very low levels of metal atoms. That's strange because stars create heavier elements over their lifespans. Low metallicity suggests these stars formed in the early universe, and that changes everything we thought about galaxy evolution. Euclid also revealed several previously unknown globular star clusters and HII regions in this galaxy. HII regions are the colorful gas clouds you see here. When stars are born, they emit light so strong it ionizes the hydrogen gas around them. These glowing clouds mark stellar nurseries. Globular cluster NGC 6397 sits 7,800 light-years from home. That makes it the second closest globular cluster to us. Globular clusters pack a high concentration of stars in one place. Everyone's trying to outshine everyone else, and that creates a problem for scientists. The smaller, dimmer stars get drowned out by the bigger, brighter ones. These faint stars extend far out from the cluster's center. And ironically, they hold the most scientific interest for unlocking the history of the Milky Way. But no telescope could see them clearly. Hubble imaged the center of this cluster in 2021. But to capture the entire cluster, including its sprawling outskirts, would have taken far too much time. Euclid snapped this shot in just 1 hour. 1 hour. And it captured everything Hubble couldn't. But the next image revealed something even more surprising, a galaxy that had been hiding from us for decades. And what Euclid found there would challenge our understanding of how spiral galaxies work. Caldwell 5, also known as the Hidden Galaxy, sits about 11 million light-years away. It's hard to observe because it lies in the busy disk of our Milky Way. Dust, gas, and other stars overshadow it. But Euclid's near-infrared instrument pierced through all of that. This galaxy looks similar to our own Milky Way. That makes it a prime target for researchers. It's pretty hard to study a galaxy you're inside of. You only get to observe it from one plane. The Hidden Galaxy gives us an outside view of what our home might look like. We can now trace the history of star formation in this galaxy. We can see how stars formed and evolved over billions of years. We still don't fully understand how spiral galaxies keep their shape. Euclid's detailed images of dust lanes and spiral arms will help answer that question. Our final stop is the best one. The Horsehead Nebula has been photographed by various telescopes before, but never with such a sharp and wide view as Euclid managed. And this shot was taken in just 1 hour, like someone stopped at a viewpoint and snapped a picture. But scientists found something hiding in these clouds, something that nobody expected to find in such large numbers. And it would change how we search for planets throughout the galaxy. Located about 1,375 light-years away, this is the nearest massive star-forming region. The clouds behind the Horsehead are lit up by UV radiation from nearby star Sigma Orionis. The Horsehead itself is made of cold molecular hydrogen. It gives off barely any heat or light. Scientists hope to find Jupiter-mass planets floating freely in this nebula. One such planet had already been identified. Sori 62, a young planet 10 times the mass of Jupiter with surface temperatures of 2,200 degrees Fahrenheit. But Euclid found many more smaller ones than anyone expected. Free-floating planets were known to exist near Sigma Orionis, but with Euclid's ultra-high sensitivity, scientists found many smaller ones than were previously documented. As one research paper put it, these planets appear to be everywhere and numerous. They're far more common than we thought. This is just the beginning. With another 5.5 years of mission time left, Euclid still has a lot of ground to cover. The data it collects will help scientists understand dark matter, dark energy, and the origins of stars and galaxies themselves. A 3D map of dark matter distribution could change our understanding of fundamental physics. Every image Euclid sends back reveals something new about the cosmos, and we're only at 1% of the mission. The universe still has plenty of secrets left to share with us.